Hi everyone. Thank you for taking your time for my session, Building Scalable Semantic Search. I'm Kaz Sato, developer advocate from the Cloud AI team. So in this session, I'd like to discuss these topics. First, I'd like to introduce a new product, Vertex AI Vector Search 2.0. I will call it as VS2. Second, I will use the look dataset, which is a fashion item dataset with the 30,000 fashion items, to understand what are the benefits you would get by using VS2. Lastly, I'd like to discuss how to extend VS2 with ADK, Agent Development Kit, to build an agentic RAG system. So let's get started with VS2. Vector search is a foundational technology for modern AI services. It uses high-dimensional embeddings. That means it's a bunch of numbers, for example, 768 real numbers that captures the meaning of the contents like text, images, or video, or product items, and so on. Vector search powers various search services, recommendation systems, and RAG or AI agent systems. For example, Google rely on the vector search technologies for billions of the daily searches and recommendations on Google Search, YouTube, and many other major Google services. Let's take a look at the demo of the vector search. For example, in this case, it enters cups with dancing people as the query text. Then instantly, it finds the result from the 3 million items. Just like that, another query like cups with Google logo colors understands the meaning of the text and finds the item images that had similar meanings to the query, as you are seeing now. So that was the vector search, but there has been many challenges to build a production vector search setup by yourself. And VS2 provides many new functionalities that solves those challenges. For example, the first challenge is the embedding generation. In the past, you had to build a data pipeline that passes the data to the embedding model. For example, we provide a Vertex AI Embeddings API that converts the content like text or images into an embeddings. So you have to generate the embeddings by yourself and then pass the embeddings to the vector search to build the index. So the index building pipeline could be a nightmare for the developers. With VS2, it provides a new auto-embeddings functionality. That means all you have to do is just pass the text field to the VS2, and the VS2 under the hood does everything for you. It automatically calls the embedding models and generate the embeddings. Second, you have to handle the feature set by yourself. So with the previous version of the vector search, all you get with the search result is the list of the IDs. That means you have to set up your key value store or feature store that converts the IDs into the item fields like product names or pricing or categories. With VS2, you don't have to set up a feature store by yourself anymore. It has the unified storage that works just like the key value store or the relational databases. So all you get as a search result is the actual raw the data, like product names, the price, and categories, so on. Third, the tuning. So the tuning for the ANN index is the nightmare for the developers for building a production setup. ANN stands for the approximate nearest neighbor algorithms. That is the key technology for this vector search that allows you to find the relevant items from the billions of the items in tens of milliseconds. But it requires a very the high expertise on tuning, like how many shards you want to use for splitting the data into different nodes or the instances, or what is the best balancing between the recall rate or accuracy and the latency. With VS2, everything is automated. all you have to do is just dump your data into the VS2 index so that it automatically scales out into the multiple shards, and also it takes the best balancing between the recall rate and latency. Lastly, hybrid search. Semantic search provides the very powerful functionality to understand the meaning of the content, but it cannot find any data that doesn't have any meanings or semantics. For example, if your user makes a query with product names, product IDs, or SKU, because SKU or product ID doesn't have any meaning itself, it cannot be handled by the semantic search at all. But still, as you know, the users would expect the search engine to find by the product ID. Or maybe you would add a new product item that has a brilliantly new names that never existed before. In this case, again, the embedding model doesn't understand the meaning of the new product names, so the semantic search doesn't work. So in those cases, you have to have another search engine, full text keyword search engine. So all you have to do is having two different search engines, semantic search and keyword search, and running them in parallel, and combine the result into a single search result. With VS2, you don't have to do that anymore. Because we embedded everything into a single product, we provide a built-in hybrid search that has the semantic search and also full text keyword search. So as you passes the keyword, a query keyword to the search engine, you'll be getting the end result that has the merged result from both engines. So let's take a look at the actual demo that shows the power of the VS2 with the look dataset. The look dataset is an e-commerce dataset which has 30,000 fashion items like this one, which has product ID, product name like a shirt or pants, and category, and retail price. It's a very simple dataset. And we'll be building a product search system by using VS2. In VS2, we have introduced a new concepts called collection and data objects. Collection is like a table in relational databases, where you define the data schema of each fields like ID or name or category and so on with those data types. And also it defines the vector schema, like how many dimensions, like 768 dimensions for these embeddings, and what kind of the embeddings you want to generate with that vector. And once you have defined the collection schema, you can insert the data by using the data objects that wraps the raw data as the objects. Finally, you may build an ANN index, the approximate nearest neighbor index, that scales up the systems to support up to like billions of the items that could be searched within tens of milliseconds. Let's take a look at the demo of the VS2. Once you have installed the SDK, you can start defining the collection like this. So let me hold on the video. So here you see that it defines the data schema here with the properties like ID, name, and category, and retail price with their types. Oh, let me go back to the video. Okay, installing the SDK. And define the collection with the data schema. And the second thing you would want to define is the vector schema. It defines the name dense embeddings as the vector schema that has 768 dimensions. And you specify the name of the embedding model. That is the name of the embedding model that is provided by the Vertex AI embedding API. So once you have defined the vector the schema, the embedding will be automatically generated by passing the name field to the embedding model. So now you can start importing the old data to the collections by wrapping the data with the data objects. So in this demo, we are using 10,000 samples from the 30,000 data set imported into the index. So now it's ready to get started. So in the previous version of the vector search, you had to wait for like 1 hour before get started with the search or query, because you had to wait for building an ANN index with those data set. But with VS2, it's much, much easier and fast. As soon as you define the data schema, the collection, and imported the data set, then you can get started with the filters and the query, semantic search, and hybrid search instantly. In this example, it defines a filter, search by filter, where it tries to find all the items that has category equals to genes. So by running it, you can get the list of the all items that has the category equals to genes. Here's a hybrid search example where you define the semantic search that uses the embedding and passes the query text, means short for beach. So this semantic search can find the items that are relevant to the query. And you can also define the text search as well. And this is the combined result from the semantic search and text search, like the men's shirts and the fashion search and so on. And this result is re-ranked by using the RRF algorithms automatically. So this was the example. As I mentioned, there's 2 different engines embedded in the VS2. Semantic search engine with the vector search and Vertex search engine. And it runs those 2 searches running in parallel and uses reciprocal rank fusion algorithms to re-ranking them into a single merged result. So this is a complete picture of the steps I have taken in the demos. First, you would define the collection with the schema. You imported the data by using data objects. And you can get started with hybrid search, or maybe you can add filters for the complex filtering the conditions. So from the step 1 to step 4, you can only take like 10 minutes in case of the look data set. And also, if you want to scale it up to support the millions or billions of the data sets, then you can add ANN index that allows you to get the fast latency like 10 or 20 milliseconds with the millions of the data set. Okay, so that was what kind of the benefit you could get by using the VS2. Lastly, I'd like to show how you can build an agentic RAG system by combining the ADK and the VS2. In this case, we'd like to use this scenario, AI travel agent, that uses the 2000 London Airbnb listings, and ADK as a reasoning layer to the VS2 for agentic search. What do you mean by the agentic? So agentic means it has the reasoning functionality that decomposes the user request into the hybrid search query and the filter conditioning, and call the VS2 as a tool. Let's take a look at the demo. So first, you would define the ADK tool. ADK tool is just a function in Python. It defines how to call the VS2 for a request from the agent. But the thing is, you have to define the functionality in this doc string. As you can see, there is a very rich explanation about how this function works to find the items. For example, it takes 2 parameters, query and filter, and query for the hybrid search and the filter for the filtering. So with this doc string, the agent understands how to use this tool and how to call it with the parameters. And inside of the tool function, you can write the usual logic to call the VS2, like a semantic search, and the text search and combine them as the hybrid search. Then you can define the agent by using the tool. So in this agent instruction, it defines the instruction like you are an expert London travel agent, helping users to find vacation rentals. And also it defines how to use the find rentals tools, like how to build the filtering expression, like to find all the rentals pricing under £200, you can define the filter like this. Now it's ready to get started with the demo. So by running the agent with this simple query, like I want an inspiring workspace in Hackney, then it's built on filter and query like this. The query will be inspiring workspace as the hybrid search, and the filter will be neighborhood equals to Hackney. So you'll be getting the result like this instantly. Let's try another complex example. Here, the user is trying to find a creative artist workspace in Hackney under £200 that I can book instantly. This will be converted into a filter like this. Query is the creative artist workspace. Filter combines two different conditions. Neighborhood equals to Hackney, and price less than 200, and instantly bookable. So you'll be getting the right result, the relevant result, based on the user query. So that was the basic part of the agentic RAG. You can extend this functionality with the advanced agentic RAG techniques, such as the parallel query strategies, where you would have a sub-agents to generate the tens of different queries and run them in parallel. Or maybe self-RAG to make an iteration over the different the searches by changing the query text, or adaptive query routing. Or you could even have the multiple different correction of the VS2 and let agent to choose the right one. Or you can even combine the VS2 with the knowledge graph databases. Or you can use the session memory or long-term memory functionality provided with the ADK. And lastly, you can deploy everything into agent engine to get the production quality agent ops or observability for the production deployment. So that was it. Let's summarize. So I have introduced a new product, Vector Search 2.0, that doesn't require any rocket science. It provides the auto-embeddings functionality and unified storage, self-tuning functionality, and built-in hybrid search engines. And lastly, I showed the combination of the VS2 with the agent development kit that adds the reasoning layer, so that even with the very complex, the vague request from the user, it can be decomposed into the semantic and hybrid search query combined with the complex filtering expression. So if you are interested, please take a look at the blog posts and samples, so you can actually run the demo I have shown by yourself. So that was it. Thank you so much.